Hello everyone, thank you so much for coming today. My name is Taylor Brown, and I am a type of biomedical engineer called a regenerative engineer. What this means is I look to be inspired by how the body works when it is healthy to design new therapies to treat the body when it is diseased. Our bodies are built with many different tools to help themselves heal and regenerate, starting from the time we are born. You may remember back when you were young, playing outside and getting a scrape on your knee, and this healed fairly quickly, because when we're young, we have a great capacity for healing and regeneration. As we start to age and we become adults, we don't heal quite so quickly, but we are typically able to recover from minor injuries. However, as we continue to age and we move into our elderly years, it becomes much more difficult for our body to fix issues as they arise. And there are many classes of diseases that we see popping up as we become older in age. One of the biggest disease types where we see big issues as we age is in the cardiovascular system. As we are aging, different things start to affect how blood flows from our heart out to the rest of our bodies. And this is important because that helps all of our tissues stay alive and healthy and perform their natural functions. If our arteries begin to be blocked, as they do when we age, this causes problems in many of these tissues. The arteries become blocked by things like overgrowing cells or accumulation of fat molecules, and this happens in places like our brain, our heart, and also in our legs. If it becomes bad enough, this blockage can start to lead to really bad damage. For example, in our legs, when this blockage occurs, if it happens for too long over time, the leg tissue itself begins to die. In order to stop this from happening, vascular surgeons will have to perform very invasive surgeries to either remove a vein to use or put a completely artificial tube into a patient's leg to resupply that blood flow so that the leg can continue to live. And there are very talented surgeons out there doing this work, but unfortunately, by 5 years after the time of this procedure, only 50% of the tubes we chose to implant will still remain open. The other 50%, they will have failed for some of the same reasons that our original arteries became diseased. They will be clogged by things like fat and overgrowing cells. This problem has been recognized for decades, and scientists and doctors and surgeons have worked to stop this with many materials and drugs, but today we still see this problem in the clinic. So what can we do to have new solutions to this problem? This is where I think we can take additional inspiration from the body. And in my work, we look to the nerves. What is interesting is that in all of our bodies right now, our arteries are surrounded by networks of nerves. In these images, you can see the green represents nerves and red represents our blood vessels and our blood vessel cells. These cells communicate with one another from the time before you are even born, helping each other grow out into your arms and legs. And they also continue to communicate as we age to tell the blood vessels when to do things like contract or dilate in order to tell blood where to go in the body. They also tell them things like how to be healthy and strong and muscular like the cells they are supposed to be. So this signaling is very important, and it's something that we can study as an idea for developing new therapies. I study this in my work in 2 ways. The first is to take the nerves away and see what happens, and the second is to add nerves back with therapies to see if this can lead to helpful effects in our blood vessels. Now, the first approach, taking the nerves away, now it seems probably a little counterintuitive. I've just told you how important these nerves are. Well, in biology, a lot of times we start to study how important something is by taking it away. And this is similar to many love songs or movies where you don't know what you've got until it's gone or you don't have it anymore. Here in biology, we do it with things like our nerve cells. So I have used a special chemical to remove the nerves from one leg in a mouse, and then we can see what happens with those blood vessels. Here in these images, you can see areas of the foot of a mouse that have good blood perfusion, as shown by large amounts of red or white coloring, versus those with lower perfusion or lower blood flow in the blues and greens. When I took the nerves away and we cooled a mouse down and cooling is a way that we can sense how our nerves are working because that's a time that they send signals. We saw that the leg that has a reduction in the nerves also shows a reduction in the blood flow of that treated leg. Now, this is a very complicated system, so we're still working to understand exactly how this happened, but it does speak to the effect that the nerves are an important part of regulating the blood flow in the legs. Now, the other half of my work is a little bit more straightforward in idea, at least, in that we want to add nerves back in new therapies and see what that can do for our tissues and for new blood vessel technologies. The first project I'm showing here is one where we use a conductive material, or something that can pass along electric signals, and we coat some of the tubes with this material. Here you can see a tube we use go from white to this dark color when it is coated. And the idea here is that electric stimulation can be something that helps nerves to grow, and it can also be something that helps our vascular cells to grow. So by coating the tubes that we want to put into a patient's leg, we may be able to regulate both of those cell types and lead to longer-lasting therapies. The second approach that I am taking during my PhD is to design a delivery device that can release signals around any type of tube that we implant or around any disease vasculature. Here, we can include different signals that might have happened during development. We can include them in these tiny bubbles that are colored in blue on the slide. And over time, they can be released around the blood vessel when we deliver them in a very special gel. This gel could be added as soon as a surgeon adds in a new tube that's either a used vein or an artificial tube that they used. They can coat it with this gel to tell the nerves that you need to come grow back, even though our patient is now elderly. It can learn from the process that we had during our growth before we were born. Now, these ideas are hopefully just the beginning of a new way of being inspired for blood vessel technology by their native anatomy and communication that happens between cell types. If we can learn more about this communication, we can come up with better therapies for not only cardiovascular engineering, but hopefully other types of problems and diseases as well. The idea is that if we can learn from new strategies and come up with better therapies, we may finally be able to come up with tubes or therapies for vascular surgery that will last for a patient's entire lifetime. Thank you.